In this video we're going to look at geometrical interpretation of complex number equations and inequalities. Begin by looking at the case of the modulus of z. And remember that the modulus of z really represents the distance of a complex number z from the origin. So given an equation modulus of z is equal to 3, then this is really representing all complex numbers z that are exactly 3 units from the origin. So now representing this geometrically, this is going to correspond to the set of all complex numbers that lie on a circle of radius 3 and center at 0, 0. This is represented by the following simple sketch here. So we've got a circle drawn in an Argand diagram, axes, the imaginary axis and the real axis, and the radius of the circle lies 3 units in all directions from the origin. So touching at the axes at 3 and minus 3. We now use an algebraic approach to solve our equation, and we want to show that the solutions that we get are the same as the solutions that we've shown in the first part of this video. So in other words, we want to confirm that the equation modulus z equals 3 does indeed have solutions that lie on a circle with radius 3 and center 0, 0. Just introducing a little bit of notation now. The set of solutions that satisfy the equation are referred to as the locus of the equation. So in this case, the locus of the equation modulus of z equals 3 is shown by the diagram here. To solve our algebraic equation, we're going to begin by letting z equal x plus yi, where x and y are both real numbers. So therefore we get the modulus of x plus y equals 3. Applying the definition of the modulus, we get x squared plus y squared. The square root of x squared plus y squared equals 3. Squaring both sides, we get x squared plus y squared equals 3 squared. Now if we graph this equation using the built-in maths tools in OneNote, and we graph our 2D equation, we see here we've got, as before, we've got a circle with center 0, 0 and radius 3. Now we just recall at this stage that given an equation of the form x take a squared plus y take b squared equals r squared, this corresponds to a circle that has center AB and radius of r. So therefore our equation x squared plus y squared equals 3 squared from the above information corresponds to a circle with center 0, 0 and radius of 3. So really again confirming what we found in the earlier part of the video. So having found the locus of the equation modulus of z equals 3, we'll now turn our attention to an inequality. So in this case we're going to look at the modulus of z is less than 3. So geometrically what we'd expect is we'd expect to see this corresponds to all complex numbers z which lie less than 3 units from the origin, or are less than 3 units, are within 3 units of the origin. So the inequality that we get from this, derived from the previous part of the video, is x squared plus y squared is less than 3, or 3 squared. So rather than equal to 3 squared, we just write less than 3 squared. Now graphing that then, again using our OneNote built-in math mode, we graph the inequality. If we enlarge that slightly, we see here we get a circle radius 3 where all of the points within the circle are shaded. Note that the circle itself is not included, so it's shown as a dashed line, which confirms the fact that it's less than 3. So in other words, points on the boundary of the circle are excluded in this case. So the next case to look at or compare to is modulus of z is less than or equal to 3. So in this case the equation or the inequality becomes x squared plus y squared is less than or equal to 3. And when we graph that, so graphing our inequality, again we see we've got a circle that's shaded in, but this time the boundary is actually included or is shown as a solid line. So the very last case for comparison is the equation modulus of z is greater than 3. So the equation in this case becomes x squared plus y squared is greater than 3 squared, which gives us this graph here.